Finally, to review the chi-square distribution and testing multiple proportions. What are the hypotheses options for multiple proportions? What are the tests for multiple proportions, and how do you decide which test to use? And what do you present for testing multiple proportions? In phase 1, remember we need to state the question. This is steps 1 through 3. Step 1 is evaluating and describing our data. Step 2 is reviewing the assumptions. And step 3 is stating the question in the form of hypotheses. Make sure you display your results in a contingency table. You could also do a figure if that's appropriate. And then think about, is the question testing homogeneity, association, or independence? Are we looking for similarities? So that's homogeneity. Are they going to be different? That's heterogeneity. Are we thinking these two variables have an association, or are we thinking that they are independent of one another? You'll want to review the assumptions, so representativeness, independence, and sample size. Do the calculation of expected sample size. Remember, the rule for multiple proportions, and actually for any type of proportion, is more than 20% of the cells have expected counts less than 5. From there, you'll want to state the form of the hypotheses. So remember, homogeneity is going to compare proportions from different groups and ask, are they the same or different? Homogeneity is the same, heterogeneity is different. A relationship asks if two variables are related. And then independence looks for relationships between classification variables and asks, is there an association? All of these hypotheses are the same test. It just really depends upon how you want to frame the question for your data. Then you move on to phase 2 to decide how to answer your question. So you will pick a summary statistic that reflects your question. So based on step 2 sample size assumptions, if they are met, then you're going to use a chi-square test. We prefer a likelihood ratio test because it is more robust to departures from your assumptions. If your sample size is in fact too small, then you'll either have to collapse cells and go back to chi-square. Remember, if you collapse your cells, you still need to check the sample size assumption. Sometimes collapsing cells won't fix your sample size issue, and the only option you have left is Fisher's exact. I caution you here to not ignore the sample size assumption. If you ignore it and you use chi-square, then your chi-square results are not valid. The chi-square test requires the sample size assumptions to be met. Now, if you meet them or if you don't meet them, you can still use a Fisher's exact. You can err on the side of caution and use a Fisher's exact, or if you don't meet the sample size assumptions, you must use the Fisher's exact. Remember, again, we're looking at what we observe versus what we expect. So departures from what we expected will give us large test statistics. Those will give us small p-values. Those will have us leaning towards the alternative. If what we observed is close to what we expect, then we will see small test statistics and consequently large p-values, meaning that the likelihood of what we saw is pretty expected, and so we would expect to see it. It's not rare, and therefore we lend ourselves towards the null hypothesis. Our decision rule hasn't changed. Reject H0 if our p-value is less than 0.05 or less than alpha in general. Small p-values mean the alternative. We can squeeze our way to the alternative with a small p-value. Phase 3 is where you answer the question. This is steps 7 through 9. Once we've gone through the sample size assumption and we've chosen our test statistic in step 4, we're going to calculate the statistic in step 7 and get your p-value. From your p-value, you will make a statistical decision in step 8. It is less than our alpha, so you will fail to reject if our p-value is large, or we will reject the null if our p-value is small. From there, we can state the substantive conclusion. Put your results in words of your question. It's not simply we've rejected the null and the proportions are different. We need to say that the proportion of people reporting health status at 1 year is different between the ECMO and conventional management groups. That would be your substantive conclusion. Phase 4 is communicating the answer to the question. That's step 10, where you document your understanding with text, tables, or figures. You will need to show the contingency table, or you could actually show the proportions in a figure, but you do need to show the N somewhere. Remember, you can't recreate the data if you don't have the N's and proportions. So be a good citizen of reporting results and give clear information so that your results can be replicated. If there was a significant result, then you can look at the cell chi-square values. You'll find these in the same place that you find the expected counts or the deviances in JUMP. Cell chi-squares will point you to what is interesting. Cell chi-square values greater than 2 indicate something unexpected. You can see the section 10 notes for further details. But basically, you're looking for a departure from what you expected. So take a look at your expected counts versus your observed counts and see where you're seeing a difference that is large. And the cell chi-squares will tell you that. It's also very important to go ahead and talk about what wasn't different than what you expected. So write a sentence with your conclusion. Include the type of chi-square test that you did. Remember, it is imperative to say that it's a Fisher exact test. With a chi-square test, you can report the test name and the value and the degrees of freedom and the p-value, though eventually you will get down to saying it was simply a chi-square test and reporting the p-value. If it's a Fisher's exact test, you need to say it was a Fisher's exact test, and then you will only report the p-value. If there was a significant difference, write sentences in words using your outcome names, not variable names, not level 1, level 2, but write out what the words are and what that means for your reader. And also make sure to make a comment where things weren't different from what you expected. So it may turn out that there's only one row or one outcome that was really imbalanced. And the rest of them may have sort of been somewhat equal. So you may only need to point out that the better than group was very far apart, but the rest of the groups only had small differences. In general, remember, we're looking to see if proportions are the same or if they are different. If they're the same, then you expect each group to have proportions similar to the average proportion. So ignoring the columns, you would expect that each column would have a proportion similar to the overall proportion in that row. If they are different, then you would expect to see departures from the expected average proportion per response. So look at your overall data, look at the proportions in each response, that's your expected proportion. Then split it up by your groups and take a look at what is expected and what was different. In other words, you could say the proportions across the groups were the same or different. There was no association between the groups and the outcome versus there was an association. Our two variables are independent of one another versus the variables are dependent. Or there is a relationship that exists between the two variables versus the two variables are not related. Regardless of your test used, likelihood ratio, Pearson, or Fisher's exact, large p-values for those tests means we saw what we expected to see under the null and will continue to believe the null hypothesis, aka fail to reject the null. Small p-values mean we saw something unexpected. We've seen something rare that we did not expect to see under the null hypothesis, and we are therefore going to choose to believe the alternative hypothesis or reject the null hypothesis. You need to summarize your results in a way that is clear and concise. You do not want to leave the summary up to your reader. Invariably, they will make a mistake. Use a table and or figures to report your proportions. In the multiple proportions case, you'll generally have too many proportions to report that words alone. It will be very confusing if you're trying to report 10 individual proportions and make the comparisons. So, reference your table or put them in a bar chart or some other figure that makes it obvious the two proportions that are being compared in each row, or it could be multiple proportions being compared in each row. Just be clear and concise. Set the stage by telling about the data and the sample and the experiment. Check the assumptions. Do the correct test. Make your statistical decision. Put it back into words and describe the whole story for your reader. As a statistician, that is our goal. To follow the correct steps to tell the story of our hypotheses.